sketch the graph of the rational function. For graphing rational function, there's a lot of steps that we need to go through. The first thing we'll do is just the domain. You always want to know your domain of your function, no matter what you're graphing, whether it's a rational function, polynomial, logarithmic function, whatever it is, you want to know the domain. So to find the domain of a rational function, we need to have our factored form. So we will factor our numerator, if you're not clear on factoring, you can brush up on that. I'm not going to go through the whole process. So we get 2x minus 1 times a 2x, or sorry, times an x plus 2. And that's our factored form for the numerator. And then for our denominator, this is an x plus 1 times an x plus 1, so x plus 1 squared. So our domain is everything except for whatever makes the denominator equal to 0. So x plus 1, we can't have be 0. So x cannot be negative 1. So our domain is the set of all real numbers such that x is not equal to negative 1. So that's our domain. And the next thing you want to do is get your fraction in reduced form. Okay, so if there are any common factors, go ahead and cancel them out. Now there are no common factors here, so we don't need to worry about that. The next thing we find is any wholes. Now wholes we get by if we cancel any factors out, and that makes it so that we're allowed to plug in numbers in the reduced form that we would not be allowed to plug into the original, then we would have wholes. We didn't do any canceling here. There are no common factors, so there are no wholes. Next is vertical asymptotes. Okay, and vertical asymptotes are the zeros of the denominator of your reduced form. So our fraction here is already in reduced form. The zeros of the denominator are just negative 1. So x equals negative 1 is the vertical asymptote. Next is we'll find our intercepts. So we'll start with our y-intercept. And the y-intercept we get by plugging 0 in for x. So r of 0. And this is actually a lot easier to plug into the original because a lot of things just disappear. So we get a negative 2 over positive 1. That's negative 2. So as a point, that's 0, negative 2 as our y-intercept. For x-intercepts, we set the numerator equal to 0. And this is where we're going to use the factored form. So we set 2x minus 1 equal to 0, and we set x plus 2 equal to 0. And that gives us x equals 1/2 and x equals negative 2. And those are the two x values for our x-intercepts. Next, we need horizontal asymptotes. Horizontal asymptotes. So for this, we look at the leading terms. So in our numerator, our leading term is a 2x squared, and in the denominator, it's just x squared. So when the degrees are the same, then the horizontal asymptote is just the leading coefficients, which in this case is 2 over 1. Okay, so just y equals 2 is our horizontal asymptote. Finally, we can sketch what we have. So we'll start by drawing our vertical asymptote. So we've got over at negative 1, we have a vertical asymptote. So there's our vertical asymptote. And then we can draw our intercepts. We've got a y-intercept at 0, negative 2. So right there is our y-intercept. And then our x-intercepts are at 1/2 and at negative 2. So at 1/2 and at negative 2. And then we have our horizontal asymptote. And the horizontal asymptote is up at 2, so 1, 2, and that horizontal asymptote. All right, and now we just need to draw the branches of our function, follow the asymptotes, and go through our points. So there's a couple things to think about. First of all, the right side of this is pretty clear. We need to follow the horizontal asymptote and go through these points. Okay, and we have to follow them in this direction because, for example, we can't turn around after crossing this and go up, because then we would end up crossing the axis when we're not allowed to, the x-axis. Okay, and we can't come down and then bounce off of that point and then come down, because then we would cross the axis again in another spot. So we know this branch looks like this. Over here, however, we've got another story. What we could do, there's a couple options. We could follow our thing, bounce off, and then go up, okay? Or we could follow and cross through and then follow down here. And so we need to know the behavior of the function at this 0. And that comes from looking at the factor that x equals -2 came from. That came from x plus 2. And what we care about specifically is the exponent. Okay, the exponent there is 1. So that means that at the 0, it looks like something with an exponent of 1, like a linear function. Okay, that means it just crosses right through. It's not going to bounce off. So we follow our asymptote, cross through, and follow the vertical asymptote. Okay. And that is a sketch of our rational function.